Welcome to our exploration of the core principles of science. Science is more than just a collection of facts, it's a systematic way of understanding the world around us. Through observation, experimentation, and reasoning, science helps us uncover the mysteries of nature and technology. In this video, we'll break down the fundamental principles that guide scientific inquiry and discovery. Whether you're a student, a curious mind, or someone looking to refresh your knowledge, this journey will provide a clear and engaging overview. Let's begin by understanding what makes science unique and why its principles are so important in our daily lives. Science is a methodical approach to gaining knowledge about the universe. It relies on observation, experimentation, and logical reasoning to answer questions and solve problems. Unlike beliefs based on tradition or authority, science demands evidence and repeatability. This means that scientific knowledge is always open to revision as new evidence emerges. By focusing on facts and data, science allows us to build a reliable understanding of the world, from the tiniest particles to the vastness of space. Now, let's look at the foundational principles that make science such a powerful tool for discovery. Empiricism is at the heart of scientific inquiry. This principle states that knowledge comes primarily from sensory experience, what we can see, hear, touch, taste, or smell. Scientists gather data through careful observation and controlled experiments. By relying on empirical evidence, science avoids speculation and focuses on what can be measured and tested. This approach ensures that scientific conclusions are grounded in reality, making them more reliable and trustworthy. Empiricism also encourages skepticism, prompting scientists to question assumptions and seek proof before accepting claims. Observation is the first step in the scientific process. Scientists use their senses or specialized tools to gather information about the world. These observations can be as simple as watching the behavior of animals or as complex as using telescopes to study distant galaxies. Accurate observation is crucial because it forms the basis for forming hypotheses and designing experiments. By carefully recording what they see, scientists can identify patterns, make predictions, and test their ideas. Observation keeps science grounded in the real world and helps prevent errors caused by assumptions or biases. Experimentation is a core principle that sets science apart from other ways of knowing. Through experiments, scientists test their ideas under controlled conditions. This allows them to isolate variables and determine cause and effect relationships. Experiments can be conducted in laboratories, in the field, or even through computer simulations. The key is that experiments must be repeatable. Other scientists should be able to perform the same experiment and get similar results. This repeatability helps ensure that scientific findings are reliable and not just the result of chance. Hypothesis is an educated guess about how things work. Scientists form hypotheses based on their observations and existing knowledge. A good hypothesis is specific, testable, and falsifiable. It can be proven wrong through evidence. This principle encourages scientists to make predictions that can be checked through experiments or further observation. If the evidence supports the hypothesis, it gains credibility. If not, scientists revise or discard it. This process of forming and testing hypotheses is central to scientific progress, driving the search for deeper understanding. Falsifiability is a key principle in science. It means that scientific claims must be testable and capable of being proven wrong. If a hypothesis cannot be tested or potentially disproven, it falls outside the realm of science. This principle ensures that science remains objective and self-correcting. By designing experiments that could potentially refute their ideas, scientists avoid confirmation bias and remain open to new evidence. Falsifiability keeps scientific inquiry honest and dynamic, always ready to adapt to new discoveries. Prediction is a powerful aspect of science. When scientists develop theories or models, they use them to make predictions about future events or observations. If these predictions come true, it strengthens the theory. If not, the theory may need to be revised. This predictive power is what makes science so useful in everyday life, from forecasting the weather to developing new technologies. By testing predictions, science continually improves its understanding of how the world works. Objectivity is essential for scientific credibility. Scientists strive to remove personal biases and emotions from their work, focusing solely on the evidence. This means using standardized methods, peer review, and transparent reporting of results. Objectivity ensures that scientific findings are based on facts, not opinions or preferences. By maintaining objectivity, science builds trust and allows others to verify and build upon previous work. This principle is vital for the progress and reliability of scientific knowledge. Reproducibility means that scientific experiments and observations can be repeated by others and yield the same results. This principle is crucial for verifying findings and building a solid foundation of knowledge. If results cannot be reproduced, they may be due to errors, biases, or even fraud. By sharing methods and data openly, scientists invite others to test and confirm their work. Reproducibility strengthens the reliability of science and helps weed out mistakes or false claims. Peer review is a process where other experts in the field evaluate a scientist's work before it is published. This helps catch errors, biases, or unsupported claims, ensuring that only high-quality research enters the scientific record. Peer review maintains the integrity of science and encourages researchers to uphold rigorous standards. By subjecting their work to scrutiny, scientists demonstrate transparency and accountability. This process is a cornerstone of scientific progress and trustworthiness. Scientific method is a systematic process for investigating questions and solving problems. It typically involves making observations, forming a hypothesis, conducting experiments, analyzing data, and drawing conclusions. This method provides a clear framework for scientific inquiry, ensuring that research is organized and objective. By following the scientific method, scientists can build on each other's work and make steady progress toward understanding complex phenomena. It's a cycle of continuous learning and improvement. Science, a hypothesis is a specific, testable prediction, while a theory is a well-supported explanation for a broad range of observations. Theories are built from many tested hypotheses and a large body of evidence. Unlike everyday use, where theory might mean a guess, in science it represents the highest level of understanding. Theories can still be revised or replaced as new evidence emerges, but they provide a reliable framework for further research and discovery. Scientific laws describe patterns or relationships observed in nature. Unlike theories, laws do not explain why something happens, they simply state what happens under certain conditions. For example, Newton's laws of motion describe how objects move, but they don't explain the underlying reasons. Laws are concise, often expressed mathematically, and are universally accepted as true within their scope. They provide a foundation for further scientific exploration and application. Models are simplified representations of complex systems. Scientists use models to understand, predict, and communicate how things work. Models can be physical, like a globe representing Earth, or conceptual, like diagrams of the water cycle. They help scientists test ideas and visualize processes that are too large, small, or complicated to observe directly. While models are not perfect, they are valuable tools for exploring scientific questions and sharing knowledge. Scientific knowledge is always provisional, meaning it is open to change as new evidence emerges. This flexibility is a strength, not a weakness. It allows science to adapt and improve over time. Even well-established theories can be revised or replaced if new data contradicts them. This willingness to change sets science apart from dogma and ensures that our understanding of the world becomes more accurate with each discovery. Skepticism is a healthy attitude in science. Scientists do not accept claims without evidence, and they are always willing to question assumptions. This critical approach helps prevent errors, biases, and false belief from taking hold. Skepticism encourages scientists to seek proof, test ideas rigorously, and remain open to alternative explanations. By fostering a culture of questioning, science remains dynamic and self-correcting. Parsimony, often called Occam's razor, is the principle that the simplest explanation is usually the best. When faced with competing hypotheses, scientists prefer the one that makes the fewest assumptions. This doesn't mean the simplest answer is always correct, but it encourages efficiency and clarity in scientific thinking. Parsimony helps scientists avoid unnecessary complexity and focus on what the evidence truly supports. Causality is the principle that events have causes. Scientists seek to understand not just what happens, but why it happens. By identifying cause and effect relationships, science can explain natural phenomena and predict future events. Establishing causality often requires careful experimentation and analysis to rule out other factors. This principle is fundamental to scientific inquiry and underpins much of our technological progress. Scientific laws are considered universal. They apply everywhere in the universe, not just on Earth. This universality allows scientists to make predictions about distant planets, stars, and galaxies based on the same principles observed here. The consistency of scientific laws is a testament to the underlying order of nature and the power of scientific reasoning. It also enables the development of technologies that work reliably across different environments. Quantification involves expressing observations and measurements in numerical terms. This allows scientists to compare results, identify patterns, and make precise predictions. Quantification is essential for experiments, data analysis, and communication of findings. By using numbers, science becomes more objective and less prone to misinterpretation. This principle is especially important in fields like physics, chemistry, and biology, where accurate measurement is key. Standardized measurement is vital for scientific progress. Scientists use agreed-upon units and methods to ensure that results are consistent and comparable across studies. Standardization allows researchers from different countries and disciplines to collaborate effectively. It also helps avoid confusion and errors caused by inconsistent measurements. By adhering to common standards, science maintains accuracy and reliability in its findings. Technology plays a crucial role in advancing science. From microscopes to supercomputers, technological tools allow scientists to observe, measure, and analyze phenomena that would otherwise be inaccessible. Technology also enables the sharing and storage of vast amounts of data, making collaboration easier. As technology evolves, it opens new frontiers for scientific discovery and helps solve complex problems more efficiently. Modern science often crosses traditional boundaries, combining knowledge from different fields to solve complex problems. Interdisciplinary research brings together experts in biology, chemistry, physics, engineering, and more. This collaborative approach leads to innovative solutions and a deeper understanding of the world. By breaking down barriers between disciplines, science becomes more flexible and responsive to new challenges. Ethics guide the responsible conduct of scientific research. Scientists must consider the potential impacts of their work on people, animals, and the environment. Ethical principles include honesty, integrity, respect for subjects, and transparency. By adhering to ethical standards, science maintains public trust and ensures that discoveries benefit society as a whole. Ethics also help prevent misuse of scientific knowledge and technology. Effective communication is essential for sharing scientific knowledge. Scientists publish their findings in journals, present at conferences, and engage with the public through media and outreach. Clear communication ensures that discoveries are understood, verified, and applied. It also helps bridge the gap between experts and non-experts, making science accessible to everyone. Good communication fosters collaboration and inspires future generations of scientists. Public engagement is increasingly important in science. By involving communities in research and decision-making, scientists can address real-world concerns and build trust. Public engagement also helps ensure that scientific advances are used responsibly and benefit society. Through outreach, education, and dialogue, science becomes a collaborative effort that reflects the needs and values of everyone. Uncertainty is a natural part of science. Not all questions have clear or immediate answers, and some phenomena are inherently unpredictable. Scientists acknowledge uncertainty by estimating margins of error and expressing confidence levels. This honesty about what is known and unknown helps maintain credibility and guides future research. Embracing uncertainty drives scientists to keep asking questions and seeking better answers. Science is a powerful tool, but it has limits. It cannot answer questions about meaning, morality, or personal values. These belong to philosophy, religion, or the arts. Science focuses on questions that can be tested and measured. Recognizing these limits helps prevent overreach and ensures that science works alongside other ways of understanding the world. By respecting its boundaries, science remains effective and credible. Science and society are deeply interconnected. Scientific discoveries shape technology, medicine, and policy, while societal needs and values influence research priorities. By working together, science and society can address global challenges like climate change, health, and sustainability. This partnership ensures that scientific advances are used for the greater good and reflect the needs of all people. Scientific knowledge informs public policy on issues like health, environment, and technology. Policymakers rely on scientific evidence to make informed decisions that affect society. At the same time, science benefits from policies that support research and innovation. This relationship is most effective when communication is clear and mutual respect exists between scientists and policymakers. Innovation is the application of scientific knowledge to create new technologies, products, and solutions. Science drives innovation by providing the understanding needed to solve problems and improve lives. From medical breakthroughs to clean energy, innovation transforms society and opens new possibilities. The cycle of discovery and application is at the heart of scientific progress. Education is essential for spreading scientific knowledge and fostering curiosity. Through teaching and learning, new generations gain the skills to ask questions, think critically, and solve problems. Science education encourages creativity, skepticism, and a lifelong love of discovery. By investing in education, society ensures that science continues to thrive and benefit everyone. Diversity in science brings together people with different backgrounds, perspectives, and ideas. This diversity leads to more creative solutions and a richer understanding of complex problems. By welcoming people from all walks of life, science becomes more inclusive and effective. Diversity also helps ensure that research addresses the needs of a broad range of communities. Collaboration is a driving force in modern science. Scientists often work in teams, sharing ideas, data, and resources to tackle big questions. Collaboration accelerates discovery, avoids duplication of effort, and fosters a sense of community. By working together, scientists can achieve more than they could alone, pushing the boundaries of knowledge further. Curiosity is the spark that ignites scientific discovery. Scientists are driven by a desire to understand how things work and why. This sense of wonder leads to questions, experiments, and new ideas. Curiosity keeps science moving forward, inspiring breakthroughs and opening new frontiers. By nurturing curiosity, science remains vibrant and ever-evolving. Critical thinking is essential for scientific progress. Scientists must evaluate evidence, question assumptions, and consider alternative explanations. This disciplined approach helps avoid errors and ensures that conclusions are well-founded. Critical thinking also empowers people to make informed decisions in everyday life, using scientific principles to solve problems and assess information. Problem solving is at the core of scientific work. Scientists identify challenges, gather information, and develop solutions through experimentation and analysis. This systematic approach can be applied to everything from curing diseases to protecting the environment. By focusing on problem solving, science delivers practical benefits and improves quality of life for people everywhere. Adaptability is a hallmark of science. As new evidence emerges, scientists are willing to revise their ideas and approaches. This flexibility allows science to respond to changing circumstances and new discoveries. Adaptability ensures that scientific knowledge remains relevant and accurate, even as the world evolves. Integrity is the foundation of trustworthy science. Scientists are expected to report their findings honestly, acknowledge errors, and give credit to others. Integrity builds confidence in scientific results and fosters a culture of respect and responsibility. By upholding high ethical standards, science maintains its role as a reliable source of knowledge. Transparency means sharing methods, data, and results openly. This openness allows others to verify findings, replicate experiments, and build on previous work. Transparency fosters trust and accelerates scientific progress. By making information accessible, science becomes a collaborative and cumulative effort that benefits everyone. Open-mindedness is vital in science. Scientists must be willing to consider new ideas and evidence, even if it challenges established beliefs. This openness leads to innovation and prevents stagnation. By embracing new perspectives, science continues to grow and adapt, ensuring that knowledge remains current and comprehensive. With great power comes great responsibility. Scientists must consider the potential consequences of their work and strive to use knowledge for the benefit of humanity. Responsibility includes protecting the environment, respecting life, and promoting the well-being of society. By acting responsibly, science earns public trust and ensures that progress serves the common good. Progress is the ultimate goal of science. By building on past discoveries, science continually advances our understanding and capabilities. Progress leads to new technologies, improved health, and a better quality of life. The journey of science is ongoing, with each generation contributing to a brighter future. By embracing the core principles of science, we all play a part in this remarkable journey. Conclusion: the core principles of science, empiricism, skepticism, objectivity, reproducibility, and more, form the foundation of our quest for knowledge. Science is a dynamic, collaborative, and ever-evolving journey that shapes our world and our future. By understanding and embracing these principles, we can all contribute to the progress of science and the betterment of society. Thank you for joining us on this exploration of what makes science truly remarkable.